So this is sort of the intersection of functional programming and Rails as well, because I'm sort of from a Rails background, and I like that Rails is super sort of friendly for beginners, and the framework that I picked in Haskell is also very friendly for beginners. So that's where the two meet. My name is Jezen. That's me on Twitter, if you want to read my sarcastic quips. Okay, so this is my general disclaimer. I have no idea what I'm doing in functional programming. I'm not a Haskell expert. If you were expecting a Haskell expert, I'm sorry. I brought this dog so you wouldn't be mad at me for not being an expert. But this is still relevant, I think, because my angle with this is that you don't really need to be an expert to get started. I think, am I really close to the microphone? That seems, I'm trying to like lean forward. I should just project more. I think this is more natural. So I think you don't really need to be an expert to get started with Haskell. I think Haskell is a smarter tool that will sort of keep all your systems in check and sort of teach you how to program as you go along. Whereas with something like Ruby or any dynamic interpreted language, you really have to be disciplined and really have to know what you're doing. And if you make a mistake, you won't always know that you're making mistakes. And I really don't know what I'm doing. I don't even have a maths high school grade. I was drunk, I think. Cool. So I'm going to talk about sort of the motivations for picking Haskell. As I mentioned, my background is in dynamic languages, so and Rails and stuff. Actually, I started with PHP, which is even worse. Any PHP people here? Oh God, I'm sorry. I'm so sorry. So, like a lot of developers, lots of PHP, lots of JavaScript, lots of WordPress, working in a sort of sweatshop slave trade thing, making marketing sites for bloggers. I don't know. And there came a point in my career where I sort of got tired of everything being broken all the time. It feels like a standard part of software development is maintaining stuff that you broke before, which is it's not my favorite thing to do. I don't like programming that much, to be honest. I'd rather sit on a beach. So to mitigate this problem of everything being broken all the time, I started looking into the whole software craftsmanship movement. Are there any software craftsmen here? Any Uncle Bob fans? Any Joe Rainsberger fans? Is this all Greek to you? It seems so, okay. So there are a bunch of nerds that take software craftsmanship and just building software like militantly seriously. And they do inspirational talks and blog posts and videos about how to design your systems, different kinds of architectures. There's a lot about TDD. TDD people? Yeah. You know what it is? Cool. So writing tests that just like verify the fundamental correctness of your system as you build your stuff. And I like this kind of stuff. I do find it inspiring. It can be a bit silly at times, people being that serious about their own craft, but I think it's nice. And it does work. I did feel that my systems were more robust after writing lots of tests. And I practiced that a lot. I learned a lot about isolated testing, so just testing one thing at a time, and then making tests run really, really quickly. Because, okay, you guys don't know Joe Rainsberger, but it's a shame, but you should go and see a talk by Joe Rainsberger. It's online. It's called Integrated Tests Are a Scam. And he talks about how if you use integrated tests for everything in your system, then the speed at which your tests run, or rather the time it takes your tests to run, will grow exponentially as you work through the system. So the tests get longer and longer. They become sort of untenable. You can't run them anymore. You can't maintain them anymore. So all the developers in your team just stop running them. And then you have untested software again. It becomes a nightmare to maintain. So to not do all the integrated tests, you do all the isolated tests, which run very, very quickly. But it takes... What? Tests make you blow your brains out. It isn't that bad. It's all right. It's worse without. So yeah, to not have a slow integrated tests, you focus on writing quick isolated tests. Um, but you have to be really good at that. It takes a lot of practice, and I practice it a lot, and it feels good. It feels good to have a sort of very fast feedback cycle. So you write a test, a very small one, and then you write the production code that makes it pass, and you're sort of incrementally working through your system and building things slowly. That feels really nice. That wasn't me. But it's not rigorous enough, because when you're writing tests, you can only write the tests that you think of. And it doesn't matter how fast you are, you're never going to be able to write the same number of tests that the system can generate for you. So if you have a compiler that checks the types that every function in your system returns and checks that all the functions are collaborating correctly, because most of the tests that I want to write in my system are testing types and testing that functions collaborate together correctly, like one object speaks to another object the correct way. And if you're doing this in an isolated testing kind of way, then you stub out all these interactions and, oh, more people. I could start again. Welcome, new people. You missed the dog. That's that's all you missed so far. A dog that's typing. So this talk is about dogs and typing. I was talking about testing. Yeah. So most of the tests that I want to write are sort of a crappy implementation of a decent type system. I don't think human beings are very disciplined naturally. Why should we be? We have machines for that. Machines are very disciplined. I think it's wrong of us to put the onus on the developer to be disciplined, or any human in our team to be disciplined. And using a strongly typed, compiled language allows us to put that responsibility back on the machine to keep us in check, rather than us keeping ourselves in check all the time. Cool. So I get this question a lot. What is Haskell good for? Like, it's funny a question, isn't it? I didn't mention that in my background, I work with a lot of sort of software as a service startups. I work now at a software as a service startup. It's fairly generic. We match like job seekers with jobs, getting bartenders into crappy nightclubs. No, great nightclubs. Sorry. And in systems like that, it's mostly just a fancy front end for a big database, right? You're doing a lot of matching records with others, which means you have a lot of objects talking to other objects. There's a lot of collaborations in the system, and a compiler will keep all these things in check for you. So I think Haskell's really good for anything very complex where you have lots of systems talking with one another. But it's also good for, I've seen people write full-on games with it, like 3D systems. Someone wrote Doom again in Haskell. Some people like pain. No, I'm kidding. Haskell's great. It's not painful at all. It's a general purpose language. You can do just about anything with it. And it's fast too. I'll talk about performance in a moment. Yeah. Okay. And deployment. So working with Ruby on Rails, there are a bunch of deployment options like Capistrano and some others, maybe Docker. I don't know what Docker's for. I don't use it. But I mentioned it, so I'm at a conference, mentioned a buzzword. Yeah, points. Nerd points. Haskell hasn't really figured out deployment yet for at least web applications. There are a bunch of different options, but none of them are fully fleshed out. I do have an answer to that, so don't look so skeptical just yet. But that can be a pain point in the beginning. If you want to learn Haskell properly, there are a few good books, but there's one in particular that you should check out. It's called Haskell Programming from First Principles by Chris Allen and Julie Moronuki. I hope I pronounced that correctly. And I'm also writing my own book. made a start. I know it's very impressive. Thank you. So I'm writing a book called Haskell but quickly because I'm really impatient, and I don't want to. Okay, so Chris Allen and Julie Moronuki, they've written this really good book. It's like 1,000 pages long, covering like end to end everything in Haskell, beginning with lambda calculus, and they're very comprehensive and very thorough. And their angle is that you should learn everything incrementally, so you really understand what you're doing, so that you don't get frustrated and then burn out. And that's good, but I want to build stuff now, so I don't think either approach is wrong. I think it's nice to learn everything. It's also nice to like build stuff and share it with people. So that's sort of my angle. Okay, so I should design better slides. I get a lot of sort of furrowed eyebrows, like, what is this? This is a web framework called Yesod. No, sorry, that's a guy that made a web framework called Yesod. The guy is Michael Snowman, and he's a very friendly man. Yesod is sort of an analog to Rails, but in the Haskell world. It feels a bit like Rails, but without all the magic. So it's friendly, but stuff doesn't just happen automatically. You don't know how the system's working, because a lot of people find that attractive, that the system just works and you're not sure how. That's not attractive. It shouldn't be attractive. That's really a false economy, because as soon as it doesn't work, you also don't know how. And that's it's a good path to insanity, I think. So, Michael Snowman, web framework, Yesod. Yesod is Hebrew for foundation, if you're into that kind of trivia. This is my really tedious performance slide. It has lots of numbers on it, and the numbers aren't important, so you don't have to squint so much. Just sort of glaze over the numbers for a second. These charts, there's two charts there, two different machines, and I picked two different machines because I think, as I said, performance talk is really tedious, and I don't think it makes sense so much to talk about performance in the web world to some extent, because you can tune a machine to work for your performance case and then use it as propaganda. You can say, like, you can tune a machine for Node.js and say, well, Node.js is really fast, so you should use it. And it's like, well, it's not that simple. There's more to building a web product than it's just straight throughput. That said, I think programmers do get excited about performance. So here's some numbers. At the bottom, these are all sort of ping pong request times, or sort of throughput. So like how many requests a second a server will serve. Right down the bottom, there's Django, which is sort of the same as Rails in terms of performance. And it's like 2,500 requests a second. And that's not bad. It's probably good enough for most people. Going up the chart, you have Node.js, which does about 11 or 12,000 requests a second. So I've been to a bunch of parties developer parties, good parties, where people start talking about web performance, and they're building things in PHP, and then I'll suggest, why don't you do it in Ruby instead? It's a bit more friendly. And they say, well, it's too slow. And it's like, well, slow for what, really? And they say, well, you should use JavaScript because it's fast. And it is faster, but not a whole lot faster. And if you really care about performance, if you look towards the top of the chart, there's in third place on the right side, WAI, which is, I think, Web App Interface, which is a Haskell server. There are a couple of different Haskell servers. And rather than 11,000 requests a second, it'll do something like 80,000 requests a second. So it is super fast. It's sort of nice knowing that performance isn't something you have to care about early on. That seems to be a big discussion in the beginning of any Ruby project, like, oh, how are we going to make this scale to lots of users and become the next Facebook? You don't have to have that discussion until much later on in the Haskell world, which is really cool. It's a C3 large EC2 Amazon machine. I don't really get my hands dirty with this stuff too much. I don't interact directly with like WAI, so I just trust that this stuff works. Because again, I don't want to know everything to be able to do something with it. I just sort of want it to work and be able to trust the system that it's working all the time and not silently failing as well. Okay, I talked a little bit about this web framework called Yesod. There's also another part that goes with that called Nix OS. And Nix OS is a Linux distribution. It's built as a pure, immutable, fully functional distribution. Those are all very sexy sounding words to nerds, especially. Is that more people? They can come in. Bring them in. Maybe leave the door open. You can broadcast to everybody. I don't mind at all. We invented portals. Make more joke moments like this so I can sort of ad-lib and pad the talk out. Okay, so Nix OS is the Linux distribution, but there's also tools that go with it. There's a package manager for Nix OS called Nix, and it's pure and immutable because it doesn't mutate the state of your system at any time. It installs packages side by side, like different versions of the same package side by side. So you don't have this issue where you update one thing and that breaks everything else. And because everything's like installed side by side and just connected to your system with symlinks, if you upgrade stuff and it fails, you can quickly roll back. Rollbacks are instant because it's just updating a bunch of symlinks. And the third part of this ecosystem is a sort of cloud sort of deployment tool and server provisioning tool called NixOps, which is what I use to deploy my Haskell project. I said that deployment with Haskell is a bit thorny before. It did take me quite a while to get comfortable with NixOps because I tried Halcyon, Docker, Heroku, Haskell on Heroku, a whole bunch of stuff that people say, oh, this is the thing, and it'll solve all your problems, it'll cure cancer, it's the best thing. I didn't get anything to work except for NixOps and NixOS. This made a lot of sense to me. And it's also really nice that if I deploy something and it's broken, it's one command to roll it back and it's instant. And I break things all the time because I'm really dumb, which is a feature, not a bug. Let's skip forward. So if you want to get started with NixOps, I have some commands here. The documentation's online, so you don't need to jot it down. Are there any security-minded people in here? Any tinfoil hat wearers? Any elite hacksaws? I can't believe I said that. Oh my god! I saw a news reporter say that on the news once. Well, no security-conscious people in here, so you won't mind running that first command, which curls an install script and pipes it straight into your shell. That should ring some alarm bells for people, but that seems to be just the way that people install things these days. So just trust me, it works. It won't blow up your system. So you install Nix OS with that one command, and then you boot it every time you log in by adding it to your run commands file. In my case, I run Zshell, so you would change that to your bash RC if you run bash or fish or whatever you use. And then you make sure your Nix channel is up to date. That sort of keeps track of all the packages that are on Nix's ecosystem on the remote server. It's a bit like when you start a new Linux system, you do like apt-get update or something to get all the latest packages. And then you can use the Nix environment to install packages that you want. In my case, I want like GHC, which is the Haskell compiler. I think it's called the glorious Glasgow Haskell compiler. It's very nice. And then Yesod for creating web projects, and then Cabal install for installing packages for Haskell. Yeah, the nice thing about this as well is that all your Nix packages live somewhere completely separate from the rest of your system. So you can't destroy anything on your system. It's very hard to break a computer with Nix. I mentioned that it's functional and immutable and pure and stuff, but it's also declarative. So that's basically you describe your system with one centralized config file, and then you just tell it to build your system, and it'll build everything from that one config. So you don't tell it install this, then this, then this, then this. I've used sort of architectural tools like Capistrano and things like that before, where you tell it do this, then this, then this, and if it fails on step B, then you have to try and fix it before moving on, or you have to like destroy the system and start all over again. You don't have to do that with Nix, which is nice. Okay, so you have Nix installed, and you want to start developing. You use, well, in the Haskell world, you have a sort of Cabal file. It's like if you're doing a JavaScript project, you have this package JSON that has all the packages in it, or if you're doing a Ruby project and you have your gem file. Your Cabal file is sort of analogous to that. And with Nix, you use this program called Cabal to Nix, which takes a Cabal file and generates a Nix expression, so it sort of marries the two worlds. And you create a shell file, and you develop from this Nix shell. And the Nix shell has has the correct path set up. It has all the correct environment variables set up, and it points all the isolated packages to your path, which means you can have different Haskell projects with different versions on the same system, and they won't collide. It used to be that when you're working with Cabal, if you have packages that don't work together, you have to just destroy all the packages and start from scratch, and it's really painful. And then that third command, Cabal to Nix, takes, again, your Cabal file and generates some application expression, which is useful for when you deploy the software later. This is my deploy process. It's again just a few commands. It's actually, when I deploy, it's one command because I use a make file. I say make, it deploys the stuff. When you're creating a deployment, you use this command nixops create with a couple of files. One to describe your network architecture, like you'll want to have a couple of machines on Amazon and maybe some database thing. And in my case, it's just one machine because I have very small projects. So you have one file to describe your network and one file to describe what each machine should look like. So that's where I describe that, okay, I want Postgres for the database. I want some custom commands to be run. I want tarsnap for backups and this kind of thing. Nixops creates a state file somewhere in your system. That's maybe one of the drawbacks of Nixops, that all of your deployment information lives inside one state file. And as far as I'm aware, it's difficult to share this amongst the team. So if you're working in a team and you're using Nixops to deploy stuff, you should probably have a dedicated build machine so that each developer would send a command to the build machine then deploys it. Because I don't know how to share that state otherwise among the team. Some people have done it. I haven't done it. I haven't needed to yet. And then, yeah, I use Nixops to deploy. And there's also some handy commands like SSHing into a system that just magically works. And now we look at some Haskell code. That's not the scariest Haskell code I've seen. It's actually a DSL that the framework Yesod gives you. This is an example of a routes file. I'd be lying if I said it was from direct from one of my systems, because I haven't named any resource thing. But a thing is a thing in your system. I think this is sort of easy enough. Can you see it? Is it easy to see? Should I duck down? I think this is easy enough to read for anyone, even if they don't know any Haskell at all. This looks the same in like a Scala project. If you use the Play framework, it looks exactly the same as this. You define some path and potential sort of components to that path, and then you just give it a name, and then you define what HTTP verbs it responds to. So right at the end, I'm saying that my thing slash some UUID, some universally unique identifier, that's a proxy resource, and it responds to the get, post, and options verbs. It says it's type safe, because if you look at the last route, I have this UUID thing there. And I think that's interesting because the compiler is protecting your system against invalid data. So if someone goes to /thing/1, 1 isn't a UUID. It doesn't match that pattern of how a UUID should look. So directly there at the router, it's not going to try and process that request. It's not going to hit the database. It's not going to go through a handler. It's just going to say, nope, it's a 404. I'm not going there. In the same way that Haskell, or that Yesod gives you a DSL for making routes, it also gives you a DSL for generating your database schema or your models in your system. There were a couple of Rails developers here, but has anyone worked with, I know Rails people have, but has anyone worked with migration files? Sort of you imperatively tell the system like, okay, create this table with this field and this field and this field and this field. And then your system changes, and then you have to sort of undo those changes, and you have to replay all these actions sequentially. It's funny, in the Rails early days, they didn't run them sequentially. Now they have timestamps for every migration, so you know which ones to run first and then next. But a long time ago, they didn't have that, which is very funny. So that your scheme would end up in a faulty state, and you won't know how to fix that. In Yesod, you don't give it an imperative list of things to do to get to a certain state. You just tell it how you want your schema to look, more or less, and it'll do the necessary actions. It'll sort of infer what it needs to do to bring your database schema to match what you declared. So that takes away a whole bunch of complexity already. You can see that I have a user in the system. The user has a name, an email, some identifier, a timestamp for when it was created, and a unique index on their email. Similar story with my email proxy model in my system. I should say as well that this is from one of my systems. I have a little project called asimpleform.com. Does anyone here have a static website? Like statically generated website? I like statically generated websites a lot, especially coming from like WordPress. It's easy for me to sell static websites to people, but it's then hard for me to explain why they can't have a contact form. So my asimpleform.com is an endpoint. There are other services that provide the same thing, but you add a form to your page, your form posts to my service, and then it emails it back to you. Really simple. So that's what this is from. I think the rest is pretty self-explanatory. This is a look at a simple handler in my system. The code isn't super important right now, but I will go through it. A handler is sort of analogous to a controller in your MVC world. You can split things up more to strictly model stuff, controller stuff, or handler stuff. And then views are a different thing in Haskell. But it seems to be that people don't tend to do that so much. People like to just have everything in one place. The nice thing about having a really aggressive compiler like GHC is that refactoring is super easy. You can like tear your code apart, and you always have confidence it'll tell you that where things are broken. Whereas with Ruby, I couldn't do that because I would be in a cold sweat like, oh shit, what have I broken? Likely everything. So in this very, very simple handler, I'll skip the first few lines. But where it says MUID, and then this like leftwards pointing arrow, and then maybe auth ID. Maybe auth ID is some function that delegates to like an authentication service, so that handles authentication for me. And running that function maybe returns me some authentication token or some authenticated user, or maybe it won't, because maybe the user couldn't sign in because the password was incorrect or something. And this sort of maybe it will, maybe it won't concept is quite important in Haskell, because it's explicitly telling you that some parts can fail, which is all systems all the time, right? Everything fails all the time. But Haskell makes it very, very explicit where things are failing, and it makes you handle those failures explicitly as well. So the line below that where it says case MUID, and that's maybe user ID of, and then there's sort of two branches, nothing and then just something. So the nothing is this failure case. So if the user is not signed in, then it sets the title of the page and renders the home page. If they are signed in, so just something underscore is like a wildcard matcher. We don't really care what the user ID is at this point. We just redirect them to my sort of dashboard resource. And that's, I think, if you stare at it for a few minutes, that's easy enough to comprehend for most people, even with zero Haskell experience. So you shouldn't be afraid of getting into Haskell because people say it's academic. It's not. It kind of is, but it's not that thorny, I promise. This is a form in my system. You declare forms. It's a bit strange. You declare applicative forms, and forget the word applicative for now. You declare them in like a controller or a handler. And that's important because a form is sort of a function in that it requires a number of fields to be valid. Like if you have a user model that takes a name and an email address, and then in your view, in a typical application, your form only has the email address, then that form's always going to be invalid, right? Because you're not giving the user the option to add in their name. In Haskell, the type system forces you to have all your fields in your forms. So if you, that sort of sounds trivial now, but if you create a form today with a bunch of fields, and then in 6 months' time, some middle management pointy-haired guy says, oh, we also want to get their Twitter handle. If you update it in one place, then you have to make sure you update it in another place as well. So if you update the model, then every form that corresponds to that model also has to have this field, and it's checked for you automatically, rather than you having to manually go and check everything in the system. So this form takes, if you see that third stanza there, where it says email proxy form and 2 semicolons, that first line with the 2 semicolons is a type signature. So that tells you everything that function needs to accept coming in and what it returns. So it takes in a user ID, and it takes in some text, something, and it returns this form email proxy object. And then the next line sort of binds those things to some variable names. So I have user ID and user email, so that text is the user email. And then the rest of the lines tell us what fields that are in that form. So that first one, the second word is a rec, and rec is for required. So that's a required field. So it'll always give the value out, because if something is optional, then you don't get the value, you get a maybe a value, which means you have to explicitly handle. That's not part of my talk. It is good to work everybody up. Thanks for spotting that. So yeah, required fields will give you definitely a value, and they're always checked by the system. And optional fields, you have to explicitly handle when the user didn't give you some field. I mean, in Ruby, this would be nil. You have to explicitly handle nils, and you have to just remember to handle nils. But in Haskell, it does it for you. It's really simple. So I'm taking some URL for the user domain and an email for where the form should point to. That the third word of the, well, where it says URL field, that has not a regex exactly, but it pattern matches on exactly on URLs. So Yesod has some helper functions for only accepting types of data like emails or URLs. So you don't have to like write it yourself. And then those last 3 lines, I'm getting the current time. That has to go in a lift IO monad and sort of glaze over that as well. But I'll say at a very high level that they make that bit complicated because the current time is always changing. Like if I run that email proxy form function now, and then in a second from now, the exact outputs will be different. right? And in Haskell, it's very important that functions have referential transparency, which means that every time you run a function with the same inputs, it gives the same outputs. But obviously, in this case, it won't give the same output because the time changes. And the same thing with the line below that, where it says lift IO next random. Random numbers are kind of a complicated thing in Haskell, because if you ask for a random number and then ask for another random number, they're not going to be the same. But in Haskell, they want function calls to always provide the same answer. And this is some cryptic stuff. In retrospect, I should have elided this slide, I think. I've given this talk a couple times before, and people just go, wait, Haskell looks crazy. It doesn't. It's not so bad. I think if you just like squint, it's easier in the afternoon after a shot of vodka, I promise. We have the same things we saw before. We derive some user ID from this function require auth ID. Before it was maybe auth ID, and now it's require auth ID, which means that this method is protected. So only people who are signed in can use this bit of the system, otherwise they're redirected to the login page. And then we say maybe user, and we're running some database action, so we're getting someone by their user ID. It's interesting that we don't have to specify from what table that we get users, because it knows what a user ID is, so it knows where to get the resource from. And then we try and get some, from my system, some proxies, because you send an email to me, I send it to you, I'm a proxy. And then we perform some action on the result of those database calls. I think the rest is fairly uninteresting. It's like what happens when the form is successfully submitted and what happens when it isn't. You redirect when it isn't. This looks the same as a lot of MVC code, I think. And again, Yesod provides you with some helper stuff like set message there, sets like a flash message. So it's available on the next page request, but not on the third. And I'll skip forward to the next one. That's it. That's all I got. So thanks very much. If there's any questions, go ahead. Sure. Mm-hmm.
Knowing Haskell going into working with something like Yesod, you clearly know Haskell as a language. It's like it's analogous to the question of how much Ruby do I need to know before learning Rails? How much Haskell is prudent to know? Because looking at the code, it is, as you noted, as you get further along the slides, it became increasingly challenging.
Yeah, that's a really good point, and that I sort of alluded to that in the beginning, but I probably didn't make that clear enough. That Chris Allen and Julie Moronuki, they say do everything start to finish, like learn the stuff, and that's a bit like when I was getting into programming, it was jQuery solves everything, right? You go to any Stack Overflow answer, and it's like, how do you sum two numbers? Oh, well, the jQuery does that. And then some more experienced nerds would get really angry about that and be like, well, why don't you just learn JavaScript properly? There's sort of an analogy there, I think, in that a lot of people getting into Rails don't learn the core of Ruby first, but because they're glued to Rails and because they have like a job to do and they have a product they want to build, to be able to implement the features they want, they have to learn just that little bit extra of Ruby, and then a bit more, and then a bit more, and then a bit more. And I think just keeping people glued to some ecosystem, just purely by osmosis, they'll learn better. And that's my case, at least. I didn't learn Haskell through just start to finish, go through the book. I learned it by trying to solve a problem, picking Haskell for the job, dealing with some pain initially, but it's been paying off since. So there's a little bit of investment up front, but the more I use it, the more I learn. And as I mentioned before, the compiler is powerful enough that it'll protect me from myself all the time. Whereas with Ruby, when I was learning Ruby, I saw that I was making lots of mistakes that could be easily prevented. I didn't really know the idiomatic way of doing things in the Ruby world. So I would throw as many testing tools, like static analysis tools. I'd use like Rubocop and Brakeman to protect me from myself. Whereas Haskell has all that built in all the time. So if you jump in, it'll teach you as you go along. Does that answer it?
Yeah.
Cool, thanks. Is anyone else? Not you. Yeah. Yes. Mm-hmm. I'm not sure exactly. I mean, you mentioned initially the maybe type, and I'll just I should really just put it back on this slide for a while, just to get some of the questions out of the way. Yeah, so you're asking what sort of guidelines there are around using maybes and stuff like that. Yes, exactly. I mean that sure. I think that's up to you really how you want to store the data in the database. And there's often this case that I'll have to sort of marshal data between the Haskell world and the outside world. Like if I'm accepting a JSON request from the outside, I know that any request from the internet is going to be dubious. It's going to have fields missing. It's going to have stuff that I don't expect. So you have this explicit bit where you transform from one type to another, and then you cover all the possible failures. I think it's the same with the database as well. When you cross that boundary, you have an explicit bit where you translate one to the other. But I'm not sure if I answered the question properly. Okay. Well, thanks. Anyone else? Was there another one? Yes. So in my there are a few ways to do it with NixOps. In my case, actually I'll say that I have a Mac, and NixOps is sort of smart enough that it knows, okay, you're building Haskell, you're running on the Darwin, I think it's called architecture because it's a Mac, and you're deploying to EC2, which is Linux. So that won't work. It knows that that won't work. So instead of trying to build it on your system and then copy the binary over to Linux, it'll copy everything over rsync or whatever it uses, and then build it on your deployment machine. And that's what I was doing initially, but I don't recommend that. I think it's a bad idea. Haskell compilation is quite resource intensive. So if you're building on your deployment machine, then while your machine is building the software, it's got less throughput, less performance to give to people using your site. In my case now, I use a Vagrant virtual machine on my system. So I build it on Linux here. It has to be 64-bit. I don't know why, but it just does. I build it on my machine, and then NixOps just copies the binary across, and then any other files it needs as well. But it's pretty hands-off in my case. Like as I said before, I don't want to have to know everything to be dangerous. I want to know just enough to be able to provide some software for people. and I don't really want to be a DevOps systems admin guy. Does that answer the question? Is that cool? Anyone else? No? Okay. Well, yeah.
Can you go to the second coding slide? The one where you do the form and email validation. More?
Is this the slide you're looking for?
Yes, this is the slide I'm looking for. Is the that last section with all the asterisks and the
These operators, yeah.
is that part of the DSL or is that part of the
That's part of Haskell. I mentioned that this is an applicative form. There are two types of forms in Haskell. There's applicative and monadic. That sounds really complicated up front, but I'll put it in super layman's terms. Applicative just means everything runs in serial. So these are all validated at the same time, and all the validation errors are returned at the same time. And if something's run monadically, then it's computed in serial rather than parallel. Yeah, and that's that dollar in the angle brackets is the infix version of fmap, and then the star inside the angle brackets is the infix of apply. You don't really need to know that to get going with it, though. That's why I sort of glossed over it. So fmap and apply, and this is an applicative form, but don't worry about that too much. I don't want to scare you off Haskell. So, yeah. Anyone else? No, we're good. Cool. Well, thanks very much.